kill the cell. So she screened about 30 to 40 cell lines, and the virus can grow and kill about 80% of them, which for an oncolytic virus is actually really good. It's very typical. No virus kills every single cancer, but this one is well up there with other viruses. And then we said, well, it's all well and good that it can infect. We want to watch it infect. So this is a movie of, in the background, the black are all cells that are uninfected. Anything that's green has been infected. So we infected, waited 24 hours, started the movie, and this is a time-lapse movie of 24 hours. And so what you can see in the time-lapse is at the beginning, there's a certain number of cells that are infected. They're bright green. As time goes on, other cells become green because they become infected with the virus. And what you also see is some of the ones that are green, the lights go out. And when the light goes out, the cell's dead. So we were able to visualize this in real time in a tissue culture dish. So by 48 hours, we only have 5 cells and they're beginning to round up and they're beginning to die. So this was really cool. Showed this at a conference, everybody went, "Ooh." So, this is the first movie of raccoon pox as an oncolytic. I know, scientists sometimes get excited about strange things. So then we said, fine, let's see if we can treat a primary tumor. Let's put a big honking tumor in a mouse and see if we can prevent it from growing or make it go away with raccoon pox. And we used a colon cancer, and we either didn't treat the tumor and watched it and let it grow, and we only let it grow to a certain size, and then we have to sacrifice the animals for ethical reasons. And then so you can see the green line, and you can see also in the survival curve that if we don't treat the animals, they die with around between 75 and 100 days. If we do treat with raccoon pox, what we can see is that the tumors don't grow very fast. They stay small. In a proportion of animals, the tumors are cured. And in another proportion of animals, we see a stabilization of disease, and then the tumors escape, which is actually quite typical. We were able to cure about half the mice, and the other half fail. And when you look at clinical trials with cancer therapies, you often see that. You see a proportion where it works really well, and then you see another proportion where the treatment fails entirely. And that's one of the things that we're really looking close at, is what determines when a tumor escapes versus a tumor is cured. So, what have I shown you? Oncolytic viruses grow, kill tumor cells, but are unable to grow in normal tissues. They are able to exploit a lot of these genetic defects that tumor cells actually use to grow uncontrolled. And they're called these multi-modality therapeutics. There's the more bang for your buck, whereas a lot of cancer drugs, you have to give drugs. If they don't work, you have to give more, and you have to give more. The viruses, you can actually give at a low level because they can replicate. They actually are self-amplifying. You don't have to keep giving more. The virus itself grows. And they're really like tiny biological machines. We can put in GFP, which I've shown you with the green viruses, but we can put in a multitude of other genes. We can put in things that stimulate the immune system. We can put in drugs that will sensitize cancer cells to chemotherapeutics or to radiation. We can do a lot of manipulation of these viruses to help them kill cancer. And so, really, I can't emphasize enough that the field of oncolytic viruses really is a Canadian innovation. I just got back from an international conference on oncolytic viruses that was held in Banff. And there are people all over the world who study these viruses, but they really look to Canada to be the leaders in the innovation. And this is just an outline of some of the viruses that are being studied across the country. Some of them have moved right into clinical trials. Some of them are still in the lab moving towards clinical trials. But really it's a group of Canadians from coast to coast who really have moved this field forward. So be proud that we're on the cutting edge of cancer research. And just so you don't think that I did this in any way on my own, this is a picture taken last summer of the lab in which I work. So it's not a small lab, it's actually a huge lab. The guy in the center with the blue shirt, that's John. He's the boss. And we have a group of mostly young people, from high school students and undergraduates through to graduate students, postdocs, and guys like John, and technicians who work pretty much on a concerted basis. And we get a lot of our money from things like the Terry Fox Foundation and from the National Institute and the Canadian Institute for Health Research, because what we do takes a lot of money. And this actually picture was taken just up the street at the cancer center in the General Hospital. So I finished early in typical Newfoundland fashion. I spoke a little fast, but I'd be willing to take any of your questions. So thank you.